This is more like revision in preparation for the end of year examination. So this paper is usually a 3-hour paper, and the mark allocation is maximum can be 150. Okay. So remember, this paper will consist of almost all the topics that were covered under physics from term 1 up until term 4. And we shall look at some sample questions and we shall elaborate more as we move on. So the format of the paper is we have instructions and information whereby all questions must be answered. And every section should be started on a new page, okay, based on this paper. The numbering answers correctly according to the numbering system that is used within the question paper, that is paramount. And then spacing your work can also be done. You know that for this paper to be done, you will need the help of a calculator. And then instruments. Under the instruments, it's basically a ruler that we might need. And then we need to show all the substitutions as well as the formula that we're using. And then our final answers need to be rounded off to 2 decimals, or 2 numbers after the comma. And then for some explanations that we need, we shall have to give some sort of motivations or reasons as to why we reach such conclusions. And then in case they give us some answer sheet that is within the question paper, we always have to detach or remove it and then attach it to our answer book. Writing neatly and legibly is a must so that your work can be easily read and then marked without any bias. Okay, so question 1 is multiple choice. So we are always given 10 options to choose from, or 10 questions, okay? And from the 10 questions, we have 4 options that we need to choose from. The best method that we can use to answer this question 1 is where we eliminate what doesn't make sense so that we are left with the most accurate option. All right. So if I look at the first question, they're telling us that various options are provided as possible answers to the following questions. Each question has only one correct answer. Choose the answer and then write only the letter, okay? Only the letter. We do not need to write the answer next to the number. Okay, so if it's either A, B, C, D, just write the letter A, B, C, D. Don't say 1.1 is mass, acceleration, and velocity. No. All right, so with question number 1, they're telling us that which of the following quantities are vectors? Okay, so we know that vectors are basically physical quantities that must have both magnitude, okay, as well as the direction. Magnitude and direction. So for magnitude, it's like it can be measurable, okay? And then the direction must be must. It must be acting in a particular format. So when we look at mass, okay, so remember we said we start with the elimination approach. So mass is not a vector. So the fact that mass is not a vector, the whole option goes, even if velocity is, even if acceleration is. So mass kills that option. Option B, when we look at electric field, okay, distance is not. Distance is a scalar, even if the rest are. So option B is also out. When I look at the bottom, I'm still having a mass. So mass is also out. So which means I'm left with option C. Remember, there has to be one correct option. Force, yes. The vector. Electric field, yes. Then acceleration. So in this case, I'll go with option C. Then 1.2, they're telling us that what is the name of the perpendicular force that a surface exerts on an object in contact with the surface. So let's assume this is our horizontal and this is our object. Okay. What is the name of the perpendicular force? So this force that acts upwards, that the surface exerts on the object. So we know that the object will exert the weight downwards. And then the surface will produce a different or counter force. So is it tension? Well, it could have been tension if we have any ropes. But in this case, we're talking about a surface. So this is out. Normal force, there's some bit of truth. Gravitational force, no, this one is the weight, which must act downwards. Kinetic friction, no, this will act horizontal if it's a horizontal surface. So B will be the best option. Then 1.3. So the tendency of an object to remain at rest or continue in its uniform motion in a straight line is known as. So this refers to Newton's first law. And Newton's first law is not the definition of acceleration. This is second law, this is third law. So what is linked to Newton's first law is inertia, the willingness or the unwillingness of an object to move. That's inertia. Then 1.4, the mass and radius of a planet A is double the mass and radius of planet B. The mass of a person on planet A is m. What's going to be the mass of the same person on planet B? Now, there are two things that we need to really look at. We're talking about the mass of a person. Okay? Remember, mass is how much content someone has. So regardless of the planet or the place, the content is still going to be the same as long as you're still intact. Okay, so in this case, the mass, in my opinion, is going to be m. The mass is going to be m. Reason being, mass is the content that an object has. Had it been that it was weight that they're asking about, then the weight is going to change since it has the gravitational component. Gravity is different from one place to another. So option A would be the most correct option based on the reasoning we have. Then 1.5, in the vector diagram below, the resultant net vector will be. So what we need to look at when they ask for the resultant net vector is how do we draw vector diagrams and how do we represent them? Remember, we have different methods. And the main or the most common one is what we call the head to tail. Okay. So if this vector is starting from here, this is our tail, then it has to go to the head. Okay. Then from here, it's a tail and then a head. So tail head, which means F2 plus F3 must give us F1. This is where we started, this is where we are ending. So this becomes the resultant. So option A will be the best head to tail method. Then 1.6, if a mag is placed on a table, the reaction force due to the weight of the mag, according to Newton's third law, is the force of, this is 1.6. Yeah? Is it the earth on the mag? No. Remember, with Newton's third law is that action and reaction will be equal but opposite. Okay? They told us the weight of the mag. Is it the table on the mag? No. If the weight is acting downwards, then that must be upwards. Is it the mag on the table? Then the mag on the earth. So this is gravitational force as a result of the Earth's gravity G. So which means the counter reaction force must be the mag on the Earth, which is option D that I'll take. 1.7, if we have two charged objects, that are repelling each other with a force F when they are separated by a distance r. The distance is now reduced to a third. The new force in terms of F will be. So from Newton's law of gravitational force, we know that F is G m1 m2 over r squared. Okay. So if it is F, the distance is r. Now they're telling us the distance is now reduced. The masses are still the same because the same object. So which means it's going to be G m1 m2, we're dividing it by r over 3. This is going to be squared. So what's going to happen there is that let's simplify this and create more or less the same thing. So it's going to be G m1 m2 over r squared, and then we divide this by 9. From our laws of fractions, we cannot divide fractions, so we normally change the sign. So this is the same as r squared over 9. So if we switch the sign to multiplication, we're just gonna have G m1 m2 over, okay, not over, times, we have 9 over r squared. Now this is the whole of that, G m1 m2 over r squared, but we have something extra, which is the 9. Okay, so if this whole thing is F, then this is going to give us 9F, which is option D. Then 1.8, in the diagram below, they're telling us the north pole of a bar magnet approaches end A. Okay. Then we have a solenoid, we have a galvanometer. Which one of the following statements about the polarity of A and the direction of the induced current is shown by the deflection? Okay. So what we can see is that the polarity, number one, is it going to be a north or a south pole? So under induced magnetism or induced current, for as long as you push the north pole towards, okay, because they're telling us approaches, it's just approaching, it's not inserted within. Okay, so this north pole will be induced by this point A. Okay, and for as long as there is that sort of induction that is happening, we know that polarity A is going to be a north pole. So it's either option A or option C. Let's look at the deflection. That's when we look at the direction of the current. So we expect this, since this is the north and this is the south, where should the current move? Where should the current move? What will be the direction of the current? Is it to the left or to the right? So if it's moving in this sort of direction, so we expect it to deflect to the right. So option C would be my best option there. Then 1.9, we have an electric circuit. So potential difference across the battery in the circuit diagram below is 10V. Okay, so our PD is 10. The internal resistance can be ignored. Okay, it's not for our level. 2 voltmeters, V1 and V2 are connected in the circuit. Okay, the diagram below. So what we can see is that these resistors are in series, which means the current that is passing across is the same, but the voltage, the potential difference is different. So when the switch is open, okay, when the switch is open, what will be the correct reading of the voltmeter V1 and V2? So one thing we know is that V1 is just connected across the terminals of the battery. So V1 is going to register the 10V. But V2 is just connected across one terminal of the battery, this one. This one is not connected because of the open switch. So this is going to be a 0. So I need 10 for V1 and then 0 for V2. which is option B. Option B. Then lastly, what is the unit for power? We know that power is measured in watts. Okay, but we know that power will be the work done over the time. And we know that work done is measured in joules over seconds. So which means it's going to be joules per second, which is option B. Okay, so that is question number 1. And then we move on to question number 2. So with question number 2, they're telling us that 3 forces, F1, F2, and F3 are applied on a crate of 15 kilograms as shown on the diagram below. Okay. First question, they want us to define what resultant vector is. So a resultant vector, a resultant force is just more like a single vector, okay, which is having the same effect as all the vectors that are combined. Okay, so I'm going to say it's a single vector that is having the same effect as 2 or more vectors combined. So which means it's one vector, but summing up all the others. Or in other words, someone can say is the sum of 2 or more vectors. I mean, that's the resultant, regardless of how you're summing them up, but it's just the sum. So that is for the resultant vector. Then they want us to calculate the resultant of the 3 forces. Okay. So with this, we have to break this into the components, resolve them into components. Okay, so if I have this as a 30, let me create my triangle there so that it is right angled. I can even create something like that so that that is my 90. Okay. So I don't know how I'm going to, okay, let me look at F1. Okay. So with F1, if I'm to look at the horizontal, which is F1H, if I'm to resolve this, the horizontal, if I'm looking at 30, that's going to be 500. This is the sine of 30. This is the opposite side of the 30. Then this one is the adjacent, which will represent my vertical. So let me call this 500 sine of 30. It's positive because it's moving this sort of direction. And then I'll have this. Remember our head to tail. So this one is also going to be positive since it's upwards. So it's going to be 500. We're saying F1V is 500 because of 30. Okay. Then if I'm to look at my F2, if this is my resultant, if I resolve into, I have this, and then I'll have this downwards. So the horizontal is in positive, the vertical is in the negative. So this is going to be 600. I'll take this normal, the resultant for 600. Since this is adjacent, will be the cos of 50. This is F2 horizontal. Then F2 vertical is going to be negative 600, but with a sine of 50. Okay. Alternatively, if you don't want to put the negative, you can use the left or right. And then we're seeing that with F3, it's on the negative side. Then when it comes to the vertical, this is F3 horizontal, it's negative. then F3 vertical is going to be 0 since there's no upward or downward direction. Okay, so then with that, we can now do the combination of all the forces, okay? We can put them together so that we can create the two components that we need. So what I'm going to do, I think I can even do it from here. Yeah, let me just switch the color so that we can plus them up nicely. Okay, so with the horizontal, I have this, which is positive. I have this that is positive. I have that is negative. Let me put this side 500 sine. So we say F horizontal 500 sine of 30, 600 cos of 50, and then we're subtracting the 450. Can punch this into our calculator. So 500 sine of 30 gives us a 250. And then 600 cos of 50 is going to give me 385,672 minus the 450. Let me just punch this at once. 385,672 minus 450, which means I end up with 185,672 newtons. So this is my horizontal component. Then when I look at the vertical, remember vertical, I have this 500 cos, this one positive. So it's 500 cos of 30. The other one that I have is this negative 600. So minus 600. Is it sine? 600 sine of 50. Okay, then when I simplify this, so 500 cos of 30 is going to give me 433. 013. And then 600, we're having sine of 50. Punch that into the calculator. I'll get 459,627. When I subtract these two, I'm getting 26, but negative, 614. So newtons. So this is my vertical. Now, or we can just give it as a positive and we say down. This one is to the right since it's horizontal and positive. Then from there, I'll have to combine these two and create my resultant forces. So which means I'll have this as my horizontal, that as my vertical. So if that is my 26,614, this is our 185,672. Remember, since the resultant force is a vector quantity, we need to find the magnitude as well as the direction. Okay. So what I'll do, which means my resultant is going to be here, F resultant. So if I bring this here, I'll have to use my theorem of Pythagoras. R squared is equal to x squared plus y squared. Or you can say that our FR squared should be the F horizontal squared plus the F vertical squared. So which means our resultant will be the square root of 26,614 squared plus the 185,675 squared. Okay, so when I punch that into my calculator, that's gonna be 26,675 614. We are adding 185,675 also squared. I'm getting 187,57 newtons. Okay, so this is our resultant force. Then we need to give the direction as well. So for us to get the direction, remember our tan theta must be the opposite of a hypotenuse. So our opposite is 26, or the vertical. So normally I say V over horizontal, which is 26,614 over 185,675 is equal to the tan of theta. For us to get the theta, it will be the shift tan or the arc tan of this result. Okay, so punching that into the calculator, where is my tan? Okay, so 26,614 over 185,675. I'm getting 8,15 degrees. So this is the resultant force at that angle. So that is how we would have obtained those 9 marks. Okay, so start by resolving into the horizontal as well as the vertical. Okay, and then after doing that, we can play around with whatever is left. Okay, so alternatively, one could also look at it with this, because if now I'm looking at, is it this angle or the other angle? So if it's this angle here, then it will be 90 minus the 8,15, and then you get your 80 something. Okay, so that is with the force and the resultant. Okay, then explain why the 3 forces will not form a closed vector diagram. So for something to give us a closed vector diagram, we know that the resultant force must be equal to 0. But in this case, we've seen that the resultant force is 187, something. So it's not a 0. So what we can say is that the resultant force is not equal to 0. So resultant force is not 0. All right, so that is 2.3 in question 2. Question number 3, telling us that a constant force F is pulling a 20 kg block at a constant speed of a rough surface XY. Okay, so there's a keyword rough. The coefficient of kinetic friction between the block and the surface is that. Okay, so the information we have is mu k is 0,2. We know that the mass is 20 kilograms. That's all we know. And we all have this angle, which is at 30. So 3.1, they want us to give a reason why the coefficient of friction has no units. In other words, they cannot give us 0,2 kilograms, 0,2 meters, 0, why? Because this coefficient is basically a ratio. That's all we need to say. Coefficient is a ratio. So if you're talking about velocities, then we say the ratio of the velocity may be the surface exerts on what, and then the blah, 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 something of the sort. Okay, so it's a ratio between the 2 forces. Then 3.2, they want us to draw a labeled free body diagram showing all the forces acting on the block. Now, guys, do not lose marks with this. So before we even get to the free body, just look at this object here, or this block. For as long as the block is on the surface, the normal reaction or the normal force is a must. For as long as it is resting on the surface, there has to be weight, or sometimes we call it the FG. Okay. Then since they told us the surface is rough and there's friction, friction must be opposite to the direction, which means we're going to have our friction that side. Okay, so Technically, we have all the forces. Then just transform this into a dotted object. So we can say this is our F applied. It's acting at an angle. So I will maintain the angle. We have our normal reaction, which is Fn. Can say this is F applied, no problem. Then we have our Fg, or you can call it the weight. And then we're going to have the frictional force, Ff. 1, 2, 3, 4. So 4 forces, 4 marks. Not bad. So we have it that way. Okay. Then 3.3, they want us to state Newton's first law in words. So from up there, I think it was one question within the objectives. We had that same thing. So we know that a body will remain at rest. A body will remain at rest or constant motion or constant uniform motion unless acted upon by a net force. Unless acted upon by a net force. If you don't want to use the word net, you can use resultant. Okay? Unless acted upon by a resultant force. All right, then 3.4. They want us to calculate the force F. Calculate the magnitude of F for 6 months. 6 months. Okay, so what we can see here is a whole lot of combination of forces. But before we even attempt the question, we need to know that this F is at an angle of 35, which means it has 2 components. Okay, we have the horizontal component and then the vertical component, which means we have to resolve this into 2. Okay, so which direction is it going to take? So if that is that, I'll have this downwards, and then I'll have this in that direction, so that this is our resultant. Okay, so having done that, we know that this is going to be F cos of 35. This is going to be F sine of 35. Then from there, I can combine my horizontal and my vertical, and it's more like a simultaneous equation that I'm seeing. Do I have space? I don't know. Okay, 2, they want us to work out the normal force. Okay, what are we going to do here? What are we going to do in this question? So we can start by saying that Newton's second law. Okay. This is 3.4.1. And say that our F net is equal to MA. Then if I'm to focus on the horizontal forces that are acting within, the direction is in this direction, not the other way around. Okay, so if I'm to focus on this, so this will be my leading applied force horizontally. So I'll have my F cos of 35 minus my frictional force. I'll call it Fk or Ff. Should give me MA. Because horizontally, it's just this and then that. Okay, Ff, or sometimes you can call it kinetic friction force. Okay. Then now, let me do my substitution and see. So this is F cos of 35 minus. We know that the frictional force is given as mu k multiplied by the normal force. But we know that normal force is given as the weight, which is mg. So I'm going to say mu k multiplied by mg should give us ma. Do we know the acceleration? Let's go back and see. The coefficient is that it's moving at a constant speed. Okay, so for as long as the speed is constant, which means the acceleration must be a 0. Let me do my substitution and see. Mu was 0,2. The mass is 20. The gravitation is 9,8 is equal to the 20 multiplied by 0. So which means F cos of 35, have to move this that side. If I put 0,2 times 20 times 9,8, that's going to give me 39,2. And then I'll divide both sides by the cos of 35 over the cos of 35. Okay. So that's going to give me 47,85. Does that make sense? Does that make sense? Let me just go back and... Oh, is it 35? Yes. It's 35, but there's something I left out by the normal reaction here. The normal reaction, because with the normal reaction, there's also that upward force, which is the sine of 35. Sine of 35 is also there, which means I have to multiply it by 2. So which means this will be sorted out with, let's just move it back a bit. Just at this page. Okay, so it's saying with the normal reaction is 0,2 times, okay. We have 20 times that, okay, but we are adding. Remember, this is acting upwards. This is also acting upwards. Okay, that's F sine of 35 must be a 0. Then that's going to be F cos of 35 minus, we open that up. Remember, we said it was 0,2 times 20 times 9,8. That must give us a 39,2. And then if we open that up, we're going to subtract. What is 0,2 times sine of 35? That's going to give us 0,11. But why don't I just leave it the way it was? Just to say 0,2 F sine of 35 is equal to 0. Okay, so I'm going to move the 39,2 that side and then subtract this. So cos of 35 is giving me 0,8192F. We are subtracting 0,2. What is 0,2 times sine of 35? That's 0,1147. F is equal to 39,2. When we subtract that, 0,8192, 0,1147. So that's going to give us 0,7045F is equal to 39,2. Then divide both sides by 0,7045 over 0,07045. That cancels that. Punching that into my calculator, I'm getting 39,2 divided by 0,7045, which is 55.64 newtons. Okay, so that's what I'm getting for the normal, for the force F. Then they want us to get the normal force. So for us to get the normal force, we know the criteria, okay? Which means we shall do the same thing and do the subtraction of that. Alternatively, we can say that normal force will be our Fg minus the F sine of theta. Okay, then our Fg is 20, which is the weight, times 9,8, minus our F sine of 35, which is 55,64, multiplied by the sine of 35. We punch this into the calculator. Whatever we get becomes our normal force. Sine of 35. I'm getting 164,09 newtons. And then 3.4.3, they want us to get the frictional force. Okay, remember frictional force is mu n. Okay, so 0.2 multiplied by the normal force that we got, 164,09. So that becomes 32,82 newtons. So that's the frictional force. Then 0.5, they're telling us that the same constant force F is now applied to a block over the same rough surface, but then the angle is now reduced to just 15. How would the frictional force in diagram B compared to that in diagram A? So they don't want an explanation as to what happens, but in this case, for as long as the angle of inclination is smaller, the frictional force is going to be bigger. Why? Because most of the force will be applied in trying to overcome, because there's going to be more of the horizontal force than the vertical force. Okay, and if the horizontal force is greater, which means even the frictional force must be bigger. So we're going to say it's higher. That is question 3. Then question number 4, they're telling us that in the diagram below, an 8-kilogram block is connected to a 4-kilogram block by means of a lightning extensor string. And then a constant force of 55 newtons is applied to the 8 kg block to accelerate the combination of the blocks to the right. The kinetic frictional force between the 4 kg block and the incline is 4 newtons. Okay. While the kinetic force between the 8 kg and the horizontal is 8 newtons. So for the 8 kg, it's 8 newtons. And then for the 4 kg, it's basically 4 newtons. Can we state Newton's second law in words? So we know that Newton's second law is the one that talks about F net is equal to mn. So the net force applied on an object will be directly proportional to the acceleration of the body, and will always take direction of the body, but it will be inversely proportional the time. Okay, so that is basically Newton's second law in just a nutshell. For as long as you know the formula of Newton's second law, then it all comes from here. Okay. Then they want us to draw a free body diagram for all the forces that are acting on the 4 kg. So the 4 kg is on an incline. Okay. So if it's an incline, we shall have this. Since it is a string, we shall have the tension. Then the weight is going to act downwards, which is the Fg. And then this is going to be the Fg perpendicular. And then this is our normal force. And then we said we have the frictional force. So still 4 marks for around about 4 forces. So if I'm to draw that separately, I'll have this as my tension, my friction, which is Fk. This is the normal force, Fn. I have my Fg, or my weight. Okay, can put this as the Fg perpendicular, but then we're also going to have another force downwards, which is the Fg parallel. Okay, so we have 2 forces that are coming down. So we have more than 4 forces, okay? Then 4.3, they want us to calculate the tension in the string that is connecting the 2 blocks, okay? So this tension here is what they need for 6 marks. Okay, so what we can do, we can look at, do we know the acceleration? Because they said a constant force is applied so that it accelerates. So we don't know the acceleration. So which means we need to get the tension. We also need to get the acceleration of the bodies. So I need to break this down. If I look at the 8 kilogram body, if I use the F net is equal to MA, I'm seeing the tension and the friction. This tension here is going to act in the opposite direction, the same direction like the friction. So I'll have the 55, okay, minus the tension minus the friction force, which is 8. This must give us MA. When I simplify this, I know that 55 minus 8 is going to give me 47. So 47 minus 3 should give us 8A. We can make T the subject. Okay, so that T is 47 minus 8A. I can call this equation 1. Then when I look at my 4 kilogram body, okay, the 4 kilogram body, just using this approach so that we can just split it up one at a time. But we can also look at it as a whole. Okay. So with that, I have my tension. So the tension is going to be leading. So we're saying F net is equal to MA. So tension is leading. We are subtracting the 4. Okay. But we say there's also the mg sine theta, the FG parallel that's acting there. So minus the mg sine of theta. I think those are the only forces. Should give us 4A. So simplifying that, T minus 4 times 9,8 sine of 30 is equal to 4A. We need to make T the subject again. Okay. So 4 times 9,8. It's giving me 19,6. 19,6 plus a 4, okay, which is going to be 23,6. So which means T is going to be 4A plus a 23,6. This is going to be our equation number 2. Then I need to solve the 2 equations, okay, equation 1 and equation 2. So which means 47 minus 8A is equal to 4A plus 23,6. If I move this that side, I'll have 12A. What is 47 minus 23.6? I'll end up with a 23,4. Divide both sides by 12. So 23.4 divided by 12, which means our acceleration is 1, 1.95 meters per second squared. The question is asking for the tension that is connecting the two blocks. So let's substitute this 1.95 into equation 1. Substitute A into equation 1. So that our T is 47 minus 8 times 1.95. Okay, so when I do the subtractions and the substitutions, I'm ending up with 31.4. So which means our tension force is 31.4 newtons. Okay, then that question will be answered. Then we move on. 4.4. 4.4. They're telling us that the angle of inclination, is decreased to 10. How will the change affect the coefficient? And we need to give an explanation. If the angle of inclination is reduced to 10, okay, so if that is a 10, how does this affect the coefficient? Now remember, coefficient is a ratio, okay? If there is ever a change within the inclination, it's only the frictional force that will be affected and not the coefficient. Okay, it's only the normal force that will be affected, but not the coefficient. Okay, so we're going to say that it remains the same. Okay, it remains the same because it is only dependent on the nature of the surface. It's only dependent on the nature of the surface. So that is what we will be having for this particular question form. Then question 5, they're telling us that a crane at a building site lifts a container that is filled with concrete. Okay. And their combined total weight is 780. The container is lifted upwards at a constant speed, capital letters, by means of a cable. Ignore the effects of friction. They want us to draw a body diagram of the container as it's being lifted. So this container here, since this is a string, it will have the tension. And since it's hanging, we shall have the weight. So we're going to have T, we're going to have FG, two forces. Then they want us to calculate the tension that is within the cable. So still from F net is equal to MA. We know that our tension minus the FG, since it's being lifted up, which means the tension must be greater, should give us the MA. The question wants the tension, which means it will be the MA plus the F of G. But we know that the acceleration is going to be 0 since it is being lifted upwards at a constant speed. So we shall only be left with FG, which is the weight, and the weight is given as mg. So that's going to be 780 multiplied by 9.8. So 780 times 9.8, that gives us 7644. Okay, newtons. So 7644 newtons becomes the tension force. Then 5.3, that telling us the crane changes the tension in the cable to 7.8. How does this change influence the acceleration? So if the force that is within the cable has increased, which means this container can move up very fast, which means the acceleration is going to increase. Okay, the acceleration is going to increase. And what is the brief explanation? It's going to be the net force. Net force will be greater than 0. In other words, our F net is not going to be a 0. But as long as not a 0, it has to increase. Then 5.3.2, they want us to calculate the acceleration after the increase. Okay, so we can apply that and say that F net is equal to MA. You say the tension minus the FG, we get the MA. So the tension is 7.8. That FG still remains the same, which is 7644. The mass is 788. Okay, this 7644, we got it from the first part, which was 5.2. When we subtract that 7.8 minus 7644, this gives us 156 is equal to 788. Divide both sides by 780 and then 780. So 156,780 gives us 0.2 meters per second squared. So this answer is still not 0. Okay, so that is how question number 5 should have been answered. We move on to question number 6. Okay, this is more about universal gravitation of Newton. Just need to know the formula and the concepts of how it works. Okay, so if we have the Earth and the satellite being separated by 1,2 times 10 to the 6. Remember, this is the surface. This is the center of the satellite. Those are two different things. Okay, which means with our calculations, we might have or need might rise for us to add the radius for us to get the distance of separation at some point. So let's keep that in mind. Okay, so the satellite of mass 1,000 kg is orbiting the Earth at a distance of 1.2 kilometers from the Earth's surface. How does the force which the Earth exerts on the satellite compare with the force that the satellite exerts on the Earth? So we know from Newton's third law and from Newton's universal gravitation that the force that will be exerted between the two will be the same. The only difference will be the direction. Okay, so here they're telling us that we must go for equal to. Answer only greater or less than or equal to. Just equal to. Do we need an explanation? No. But we know that if in case somebody needs to know why is that, you're saying when an object A exerts a force on an object B must also react by applying the same force but in the opposite direction. Oh, down here they're telling us to state the relevant law. Okay, so we're saying that when object A exerts a force on object B, we're saying that object B will simultaneously or will also exert an opposite force of equal magnitude. Okay, or you can tell us of equal size. Then state Newton's law of universal gravitation. Okay, so Newton's law of universal gravitation simply tells us that each body in the universe will attract every other body with a force, okay, with a force that is directly proportional. to the product of the magnitude of the masses. Okay, product of the masses, and inversely proportional to the square of the distance apart, or the distance between their centers. So this, get to know the formula and get to know the law itself. So everybody in the universe exerts a force, or everybody in the universe attracts other bodies with a force that is directly proportional to the product of the masses and inversely proportional to the square of the distance between their centers. Then 6.3, they want us to calculate the force that the Earth exerts on the satellite. So I think that's where we're going to have to do the addition. From our formula page, we know that the radius of the Earth, let's just confirm it. Radius of the Earth is 6.38 times 10 to get that. Which means if now we are converting this to meters, which means we have to multiply it by 1,000 again. Okay, 6.38. Let's see. So F, we said it's G. We know that G is 6.67 times 10 to the negative 11 multiplied by the mass of the Earth. We know that it's 5.98 times 10 to the 6. But I'm going to multiply again by the mass of the satellite, which is 1,000 kilograms, over the distance of separation, which means I have to add these two. So 1.2 times 10 to the 6 plus, we say that was 6.38 times 10. Let's just simplify it at once. That's going to be 10 to the 6 because that was a 3. And then we square that. When we punch this into the calculator straight away, we shall end up with 6.94 times 10 to the negative 15 newtons. All right, so that is 6.3. Then 6.4, they're telling us that the mass and the radius of planet A are this and that, respectively. They want us to calculate the acceleration due to gravity of this planet. So from this formula, this must be the distance of separation. Okay, and call it D. So our G is 6.67 times 10 to the negative 11. The mass is 7.35 times 10 to the 25. The radius is GM over R squared. So the radius is going to be, these are kilometers. When we change kilometers to meters, kilometers to meters, 1737 multiplied by 10 to the 3, and then we square that. So this is going to give us 1.62 meters per second squared. All right, so that is with 6.4. Question 7. Question 7. 3 identical spheres. We have A, we have B, we have C, are placed on a plastic or on plastic stands as shown in the diagram below. The charge on A is +5 nanocoulomb, B is -8 nanocoulomb, and then C is neutral. The 3 spheres are brought into contact. Then they want us to get the net charge after separating. So one thing we need to know is that for as long as we have spheres that are brought into contact, the net charge will be as a result of adding sphere A plus sphere B plus sphere B, or the charges, then we divide by 3. So 5 plus -8 plus the neutral one, which is a 0. Okay, when something is neutral, it simply means there's no charge there. So everything is nano. That's why I'm just saying 5 plus -8. So punching that into the calculator, I'm going to get to -3. Okay, nanocoulomb over 3, which means all the charges will go away with -1 nanocoulomb. Alternatively, you can just write it as -1 times 10 to the -9 coulombs. Okay, so that is the net charge. Then 7.1.2, they want us to get the number of electrons in excess or deficit on C after the separation. So there is a formula that we normally use of Q over E, okay, or Q is equal to NE. This is the formula that we need when we're calculating the number of electrons. So what we need is initially C had a 0, but then it gained this much of electrons. So for us to get the number of electrons, we're going to get the charge that it has, which is 1 times to the -9. It's a negative charge. And then we know that electron charge from our formula page. Okay. From our formula page, electron charge is -1,6. -1,6. Okay. So -1,6 times 10 to the -19. Okay. Punching this into the calculator, it's 1 over that times, which gives us a very big answer. I'm gonna 625 and a whole lot of zeros. 2467. So which means it's 6,25 times 10 to the 9. Because 7 zeros. So this is the number of electrons that we have. Then the next scenario, they're telling us they are then placed a distance apart, as shown in the diagram 2. So each one of them is having the same charge that they are sharing. Then they want us to draw a vector diagram showing the electrostatic forces that are acting on B due to the presence of A and C. Now remember, this one is negative. This one is also negative. This is also negative. So there's going to be repulsion between these two. Okay. So the forces will be in that direction, that direction. Then the same thing happens here, repulsion and then repulsion. So our vector diagram is going to be this, then that, the force of B as a result of A, the force of B as a result of C. So this will be our vector diagram. Then 7.3, calculate the net electrostatic force on B. So for us to get the net electrostatic force, we need to get the electrostatic forces for each individual force that we have here. Okay, so we can look at this first force, then we can look at this other force as well. So if I look for the FBA, remember it's K, Q1, Q2 over R squared. So our K is 9 times 10 to the 9. But then we are multiplying by the same force, 1 times 10 to the -9. I'm going to say squared. Over the distance of separation is 15 centimeters, which is 0,15 squared. If I punch that into the calculator, calculate the net on sphere B. Okay, I'll punch that into the calculator, 9 times 10 to the 9. And then I'm multiplying, let's say to the 9, multiplying by 1 times 10 to the -9. Okay, in the answer, we're dividing by 0,15, but squared. That's going to give us 400 newtons. So let me just focus on this, and I'll take this to be a neutral charge or a point charge. Then if I look at that other force, the BC, I'll do the same thing. The only difference that's going to change is just the distance of separation. So 9 times 10 to the 9 multiplied by 1 times 10 to the negative 9 over the 0.2 squared. Okay. If I do that, I'll end up with 225 newtons. Now, the fact that both forces are acting in opposite directions, then I'll have to subtract. So 400 minus 225. Okay, 400 minus 225, we're getting 175 newtons. Okay, but this is going to be to the left, since the left force is bigger because of the smaller distance of separation. So even if we put that other squared, 10 to the whatever, that other force, and then it's just going to be the same thing, must get the same result. Then question 8, two charges, Q1, Q2 of magnitude that, and the sign is unknown respectively, are placed in vacuum as shown in the diagram. P is a point at a distance r to the right of Q1, which is 0.2 meters, and so on. The net electric field at point P is equal to 0. Okay. Then 8.1, they're asking us, are the signs on the two charges similar or opposite? Two charges respectively placed in vacuum, point P distance that, and the net is a 0. Now, for as long as the net is a 0, okay, chances are high there's going to be repulsion, and then we have a region here where there's no activity that is happening or taking place. So we're going to say it's basically the same, or alternatively, based on what we've been given, we can say it's similar charges. So the reason for that is that for P to be 0, okay, for the net force at P to be 0, okay, we say there must be a repulsion which is created by the same signs. Okay, so the same polarity for us to get the repulsion. Then they want the electric field pattern around a positive. So this is just general. So if we have a sphere, we're calling this positive. Those will be our field lines. And what we need to show will be the arrows that are leaving the sphere. Remember, these field lines should not meet each other, but they shouldn't cross each other. So that is 8.2. Then 8.3, they want us to define what electric field at a point in words. And so we know that electric field is basically the electrostatic force. Okay, so this is the force that is experienced. The force that is experienced per unit positive charge. It's the electric force or electrostatic force that is experienced per unit positive charge that is placed at that point of interest. Okay. Then 8.4, they want us to calculate the distance r. But remember, they told us the net electric field. So we need to get the formula for the electric field, whereby we know that E is KQ over R squared. So we need the electric field at P as a result of Q1, and then that one as a result of Q2. So that's going to be 9 times 10 to the 9 multiplied by 4 times 10 to the negative 6. So that's micro. Okay. Over the distance of separation, which I don't know, I'll call it R squared. That is E1. Then I'll also look for E2 using the same formula. So 9 times 10 to the 9 times 3 times 10 to the negative 6. I'm dividing this by 0.2, but squared. Okay. Remember, the signs are the same, so they are acting in opposite directions. When I simplify the first one here, so that I just have the r squared, just going to be 9 times 10 to the 9. Okay, I'm multiplying by 4 times 10 to the negative 6, which is 36,000 over r squared. Okay. We're saying if we plus, but it's going to be minus since it's in the opposite directions. Doesn't matter at this point. Let's see. We have 9 times 10 to the 9. We're multiplying by 3 times 10 to the negative 6. That's 2.7. I'm dividing it by 0.2 squared, which is 67,000. 67, it's 5,000. Okay, so we're saying we're going to subtract the 2 and then equate to 0. Since this is to the right, which is positive, this is going to be negative, and then, yeah. So 67, 5,000 minus 36,000 over r squared. That must give us a 0. Okay, then what we need to do is make r the subject, or r squared the subject. So 675,000 r squared is equal to 36,000. Then I'll divide by 675,000 over 675,000. This cancels that. And then what I'm left with is just getting the square root. We can cancel those 3 zeros. So square root of 36 over 675. That gives us 0.223. 0.23 meters. Remember, for them to be, the charges are slightly different, which means even the distance must be slightly different. This was a 0.2, this is a 0.23. Okay, so that is how we would have obtained that distance of interest. Question number 9. Okay, electromagnetism. A coil that is having 340 tons has an area of 0.06. It's held with its axis that's coinciding with the direction of the magnetic field with this much of strength, Tesla. In order to introduce an EMF in the coil, it is pulled out of the magnetic field after that time. Now they want us to state Newton's law of electromagnetic induction. And so we know that the magnitude, okay, of the induced EMF, the magnitude of the induced EMF across a conductor, is directly proportional. Okay, is directly proportional to the change in magnetic flux linkage. The magnetic flux linkage. Okay, so that is that. Then mention 2 ways in which the magnitude of the induced EMF can be increased. 1, you increase the number of turns. Okay, and then we also need to increase the magnetic strength, or increase the magnetic strength or the magnetic field strength. I think that makes more sense. Magnetic field strength. And then we also talk about the area must be increased. Can increase the area. Then 9.3.1, they want us to calculate the magnetic flux linkage. So magnetic flux linkage, known as the phi, must be given as BA, the cos of theta. So we know that B is the magnetic strength. A is the area, and then theta will be the angle of interest. Now, for us to get the maximum induced EMF, the theta must be 0. So our V was a 0,4, the area was 0,06 times the cos of 0. Now that the cos of 0 must be a 1, so 0,4 times 0,06. This gives me 0,024. So we know that magnetic flux linkage is measured in Weber. Okay, then 9.3.2, they want us to get the magnitude of the induced EMF. So we know that the change in the induced EMF or the change in the magnetic flux will give us the EMF. So that's going to be negative N, the change in the flux over the delta T. Let's substitute how many tons we have. We have 340 tons. We are multiplying it by the change in flux, which we got as 0,024 over the change in time, which is 0,3 seconds. So 340 times 0,024, the answer we divide by 0,3, which gives us 27,2. Okay, this is going to be volts since it's EMF, it's current. Okay, that is question number 9. Question 10. A group of learners that used the circuit diagram below to investigate the relationship between the voltage across the ends of a conductor and the current passing through the conductor. Okay. Potential difference 1, 2, 3, up to 4, and that is the current. Write down the independent variable for this experiment or for this investigation. Now we know that independent variable is basically that variable that is not affected, the variable that hardly changes. So in any case, when we're talking about circuit diagrams, there is always a constant, which is 1, the temperature. Okay, temperature is one of the variables that are independent. Alternatively, one could also look at the potential difference, since this is going to represent like our X variable. So the PD can be our independent. And then the current, since it is depending on this, becomes the dependent variable. Then 10.2, name the law that learners investigated in words. So when you're looking at V and I, which law would this be? So we know that V is equal to IR. Okay, so the law that they are trying to investigate is basically Ohm's law. Question wants us to just name the law, not state it. But when you're stating it, remember, it has to be around this. Resistance is equal to V over I. All right, then 10.3, use that as answer to draw the graph of the potential difference versus the current. So 0,5, 9, 1.5, and 2. 0,5, 0,9, 1,5, and then 2. So potential difference, when it is 1, we say it's a 0,5. When it is 2, it was a 0,9, which is somewhere there. And then 3, we saw a 1,5. And then 4, I saw a 2 that was registered. And then just connect this with your ruler, and then you have your straight line that they want. Can even extend it, there's no problem till it meets the axis and stuff. Then that is the graph. Then write down the conclusion. Okay. What conclusion can we write? So the conclusion in this case, since it's Ohm's law, and the graph that we drew is a straight line, we can state Ohm's law in this case and say that the current that is passing through a conductor is directly proportional to the potential difference across the conductor if the temperature is constant. If the temperature remains constant or basically remains the same. Then 10.5, the battery in the circuit diagram below has an EMF of 14 volts with negligible internal resistance. S is closed. They want us to calculate the total resistance. So what we can see is that we are having a combination of both series and parallel, okay? So this 6 is in parallel with these two. But since these two are in series, I'll have to first of all add those two and say 4 plus 8, which is 12 ohms. Then the 12 ohms will be in parallel with the 6 ohms. For me to get that, I normally use, let me use R effective. I normally use the product over the sum, as long as I have two resistors that are in parallel. So the product will be 12 times 6 over 12 plus 6. What is that combination going to give me? That is over 18, which is 4. So which means everything here reduces to just 4 ohms. But then this result will be in series with the 3. So 4 ohms plus the 3 ohms, which gives us 7 ohms. Okay. So alternatively, you can go on and break this up and tell us 1 over 6 plus 1 over 12 must be equal to 1 over R. You'll have to do your fractions nicely so that you have 18 over 72 is 1 over R. And then you transpose or you bring about the multiplicative inverse of that, which must give you that. And then you add to the 3 as well. Then since we know that the effective resistance is 7 ohms, they want us to get the reading of the ammeter. Ammeter, we know that it is an instrument that is used to measure current. So from Ohm's law, we can say that V is equal to IR, which means our current I will be V over R. Our EMF was 14. The resistance we got was 7. So 14 over 7, that's going to give us 2 amps. Okay, so 2 amps will be our current that is passing through there. And then 10.5.3, they want the energy that is dissipated by the 8 ohm. Now, if the entire circuit is having 2 amps, we know that this 2 amps is going to be split up into the 6 and then this combination. They won't have the same, because remember now this combination is 12. It's going to call for less current. There has to be more current that is passing through the 6 ohm. But we know that for as long as we have some resistors that are in series, the voltage across is going to be different. So what we need to do, we need to start by getting the potential difference that is across this parallel combination. For us to do that, let's get the voltage across the 3 ohm. And then if we can have that, then we subtract it from the 14, and then we have the voltage across that. So what I'm going to do, I'll say V is equal to IR. Our current is 2 amps that is passing through the 3 ohms. So voltage of the 3 ohm is IR, which is 2 times 3, which is 6 volts. Okay. Now, the voltage that is across the parallel combination is going to be 14 minus 6, which is 83. Okay. Now, if the voltage is 8, for a parallel combination, the voltage is always the same, never changes. We can get the current that is passing through the 8 ohm down here, or you can get the one that is passing through the 6 ohm, and then whichever way, then you subtract it from 2. So if I look at the current by the 6 ohm, that's going to be V over the R, which is 8 over 6. I punch that into my calculator. 8 over 6 is giving me 1,3333 amps, which means the current that is passing through the 8 ohm is going to be 2 minus 1,3333. We subtract, we're going to get a 0,67 amps. We're just trying to establish the amount of current that is passing through there. Then what we can do, because I wanted to use the current part, then we can go to the formula for work. Okay, we know that W should be given as I squared R multiplied by T. The work done multiplied by T. Alternatively, you can use the voltage one. There's no problem with that. So if the current is 0,67, I'm squaring this. The resistance is 8. The time is 2 minutes. 2 minutes, we need to change it into seconds. We multiply that by 60. So 0,7 squared, we're multiplying by 8 multiplied by 120. I'm having 430,94. Since it's energy, it will be given in joules. Then 10.6. 10.6. They're telling us that the potential difference of a household supply is 2.2. A girl uses a hairdryer that allows a maximum current of 16 amps to pass through it when it's connected to the power source. Calculate how much she will pay for electricity using a dryer for 30 minutes. And this is the cost of 1 unit. So this question is just a link to what we just calculated before. Okay. So what we can do, we can just apply the same thing. You can say that the work done can be VI multiplied by delta T. If we can get the amount of work done, then we can multiply by the cost. So the voltage is going to be 220. The current is 16. The time is 30 minutes times 60, because we need it in seconds. So that's going to be 220 times 16 times 30 times 60. This gives me 6,336. But 1,000. These are watts. Are they watts? Are they joules? Okay. Then I can change this to kilo. Wait a minute. If these are watts, but these are in seconds. Okay. Which means it's just kilowatt second. I need to change it to kilowatt hour, which means I'll divide this by 3,600. Let's see if we get our answer. Divide by 3,600. I'm getting 1760. 1760 watt hour. But the unit of electricity is in kilowatt. Divide by 1,000 again, which becomes 1.76 kilowatt hour. So 1 unit and 76 points. Then I'm going to multiply this by the 2.56. Okay. 2.56. That gives me 4.5. Yeah. So it's basically 4 rands and 51 cents for you to use the hard drive. So alternatively, what one would have done is, instead of changing this to seconds, just divide it by 60. We change it to hours, and then divide by 1,000, so that we get straightforward to the kilowatt hours. Straightforward. Okay, guys, so that's what this paper entailed. Wish you all the best in your preparations.